the map data directly in the database instead of the shape files. So data, it's stored in the geodatabase, is stored in a format that's called well-known binary format. I won't go very deep into the definition of this format, it's basically actually not needed and it would be very boring. But you should know that it is standardized and was developed by Open Geospatial Consortium, and later it was actually added to an international standard. So I think it will be widely used. And it's supported by various database engines and these applications, as I will show later. So in Field-Map, there is an option to switch from storing the map data in geodatabase or in shapefiles. I will show you my example project. I have created example project and also already made the server project on my SQL server. So we have some example project with trees and many more layers, but we will mainly focus on the trees layer now. And if you look at the options, here I have this setting already set to geodatabase. So the shapes are actually stored in the database. Now I already have my data on the synchronization server. So just to show you, this example project is in Firebird, and this server project is in MSSQL. So we can take a look at the database of the server project. You can see here I have database example project x6 server, and if you take a closer look at the table trees, you can see that there are new attributes. There's this FMX point, FMX point rotation, point offset, and so on. I will go back to this a little later. But if we look at the format, it looks something like this. So it's just binary format. You won't be able to read it just by looking at it. But for example, this is point, so it has some coordinates stored in this binary data. For example, for trees or for almost every other map layer, that layer has also objects on the map, there are more than one spatial objects. So, for example, for trees, we have 3 or even more spatial called shapes. In this project, we have for each tree, we have crown projections, which is polygon. We have this tree center, which is point, and this is stem cross section, which is actually polygon. It's a circle representing the tree stem. We could also have ground profiles in here, but in this project we don't have those. So you can, so all these attributes are identified by this FMGIS prefix. So here we have them in the database. This is ground projection. This is actually some other definitions of the ground profiles and projections. And here the normal field map attributes start. So now we can try to open our server project or our server database in QGIS. So QGIS, I think it's widely used, this application, and actually can connect to any database using ODBC drivers. So you have ODBC driver for almost every database. But it has some limitation, which we will try to overcome. One limitation is that QGIS allows us only to have one geometric shape for one record. And so for trees, we have usually trees. We have those points, polygons. So we will have to make some adjustments to our database, so we will be able to connect to it in QGIS. The other limitation is that QGIS expects some table which defines what tables contain geometrical data and what data it is. So, to overcome the first limitation, that we need only one geometric attribute per table, we can use a thing that's called the database view. This is a database structure that, for example, if some of you work with MS Access, is similar to queries in Access. You define this database view, and after you define it, save it in the database, and from outside it looks like a table, but actually it's just a query that takes data from other tables. So here we can see that we have our trees table, which has some attributes, and we have to make some views in a way that each view will have only one FMGIS attribute visible. So here I have the SQL for this. It's actually very simple, so we can now create it in this management studio. So we can create view, for example, we'll call it trees point S, and we will just select some attributes from trees. So let's add ID plot, sorry, and then we need our MGIS point attribute, and we can add some other attributes we will want to use in the GIS application. So, for example, well, usually I would add all the attributes to be sure, but now we will create some simple views. So we will add, for example, DBH, height, and also species. And we also include the trees. We click on execute, and you can see the commands completed, and you can actually check. So if I now select everything from trees point, I will have some results. So I have this table. Actually, this view shows as a table. I have these attributes that I specified for this view. So, because we have more than one FMGIS attributes, I will also make one table, one view, this polygon, and also our ground projections. So let's call it ground projection polygons. So this attribute is called percent. So this is the first problem we have solved. We now have 3 tables, the virtual tables instead of 1. So we can show all these attributes at once in MGIS, UGIS.
Those views doesn't prevent any further work with field-map.
Yes.
So there are additions. They will be automatically updated when you add new trees, for instance, and new data. So as I mentioned, this is basically query result. So you do this only once. That's why my speed is important.
You only do this changes to the database once, and it's from that time it's almost there. So, and the second requirement we need to complete is to define this table geometric columns. This is needed by QGIS. So when it connects to the database, it will know that in this table will be this column and it will be of this type. There are several basic geometric types. The basic ones are point, polygon, line, and also there are types for multi-part geometric shapes. These are also sometimes used in Field-Map. Basically, you can have 2 polygons.
Only in case of multiple.
Yes, only in case of multi-polygons.
Because this trees polygon, this is a polygon of basal area. Yes? Your point is the center of tree. In the polygon is a polygon of basal area, and ground projection polygon is.
Okay, so we will just quickly create this table. I will show you how to do it. Actually, this SQL Server Management Studio is very good because even if you don't know how to write this SQL queries, you can also just open this database, look at tables, and actually create a new table. And you won't have to write any scripts, you'll just add them here. So, I forgot how it's supposed to be called. So this is _, triple name, _ geometric column, and geometry type.
So I think in the near future we will do this automatically. That this table will be created automatically because that's, or maybe on demand, like with the button.
And those are text data, so we will save it as a varchar data type. That would be very long because we will save this table as geometry. Okay, now you can look at this table. It's empty. So now what we have to do is add those 3 views to this table, so QGIS recognizes them. So this we also don't have to do by writing some scripts. We can just refresh our table list, and now we have this new table, and we can simply edit the data. So first one is called this point. Column name is MGIS point, and geometry type is point. Other is polygon, and another one is to discount projection. This is also polygon. Okay, we can now save, and if we check, we have this new data in this table. So we have now completed all the requirements we need for this to work. So we can now try to open it in QGIS. So as I said, QGIS can open any database, can connect to any database by ODBC drivers. So if some of you may be familiar with define ODBC connection, it's really a part of Windows. So if I just, there are those two tools, ODBC data sources. Now I have installed QGIS as for 64-bit application, so I will edit this in the 64-bit data source. Okay, here you have your data sources. It's empty now. And if you click Add, we can create a new data source. You can see I have here some ODBC drivers which I can use. You can also see I have installed Fiber driver, so if I use Fiber database, I could in the same way create this in the Fiber database. The SQL scripts would be actually the same, because this is just this basic SQL that in every database. But now I will select this SQL 7 native client, which is the main driver that is used for SQL servers. Now I will just define some parameters, so I will have to name my connection somehow. So let's just call it example. And server, for me it's localhost, because I'm running this database on my computer. I can define my username and password for the database. So I hope I remember it right. And also here I can actually have to define which database to connect to. So here I have the list of my databases. I will choose this example project server database. This is actually all that I have to do. And I can just skip those. Those are actually some advanced settings that you don't need to change. And if we click this data source, we should, if I already tried, should see that that's completely successfully. So I have new data sources, data source, for example project. I can now try to open it in QGIS.
This all is done only once per project.
Yeah. Also, I forgot to mention that my project also has the data is saved in global projection. This is very important, because if they have the data in local projection and they open it in QGIS, it would actually show, but it would show just as around the 0 point. If I have it in global, it will show correctly. So I create a new project in QGIS, and I can click on this Apply Vector Layer button. We can select our database, and we already have this ODBC connection selected. And we can create a new connection. Select this to ODBC. We need to name it, so let's also name it example project. Host is again localhost. Database here it's not very clear, because this window doesn't have very clear explanation of what means what field means what. So the database actually in this window means the name of the ODBC connection we just made. So I called it example server. And for username and password, we can just leave blank because we have those things defined in the OPC connection and can skip it. So we test connection. Okay, failed.
Example project, not example study.
Oh, sorry, it's example project. Okay, so we want to also specify. Okay, now the connection was successful. So it's done. We can now open our connection. And, the first thing that we will see is this, is because those attributes that are stored in the well-known binary, they don't have this information about the projection. So we will have to select our projection manually. But also this, what we only do once when we add this layer from this time on, will be shown in this projection. So I know that our project is in Czech projection system, which is SKTS. So this one. And now you can see you can select what layers can you like to add. So I will select all and click OK. Now it will also ask me for each layer because in QGIS it's possible to have a different projection for each layer, but in this case it will always be this Czech reference system. So we'll click this down. Now we have our layers added in QGIS. So let's make it nicer. Okay. And here we can make sure that we have connected to the database. If we take this open attribute table, we can see all the attributes we have. Those are these basal areas. These are the ground projections. These are the 3 points. And for example, I can now I have some orthophoto stored on my computer, so I can update some example project. So in this actually this data in this project is quite old, so I'm sure it will actually be visible. Because these are still well visible on this map. Okay. We can now just work with this as you would with any polygonal layer. I'm not an expert in QGIS, so I won't do any more operations here. But just to show you that it really works as it should, we can try to add a new tree and see if it shows here. And so I have my project open. I can just measure a new tree. I will just add it by mouse, so it's here. And let's go some attributes. So DBH will be and let's select some species. Okay, so I have created my new tree. It's actually this tree with ID 207. So now we can synchronize. To send this new record to the server. And you can take a look at this GIS and hit I click refresh, so here it will download the data, and as you can see, this screen right here appeared in this project. So you can see it's still connected to the database. Even if we change the records, some of the data, we have this connection saved, so we can use it from now on, and we don't have to make any changes. So if I want to make this connection for real in this project, I would connect all the other layers and also select more attributes, so I could use them in this QGIS.
Okay, so it was here combined with synchronization, but you should be aware that it's not necessary. For OnRide it was easier simply to write these SQL commands in MS SQL than in Firebird.
Yeah, actually it would, but in the same way you could connect to the Firebird direct Firebird database.
Okay,
Okay.
thank you. So it's